For number six, we're given a mess of data where we have concentration versus time. We've generated ln concentration and 1 over concentration versus time graphs. And from these graphs, we first need to decide what order this reaction is overall. Once we know what order it is, then we know what set of equations we can apply. So I'm looking to see whether my zero order test, my first order test, or my second order test yielded a straight line. Because this one yielded a straight line, I know that this reaction is following second order kinetics, which means the equations I can apply have to relate to second order kinetics. So I want to find the rate constant. There's two choices for how I can do it. I can either find the slope of this line, or I can plug in to the second order rate law, the second order integrated rate law, values from here and here, and then solve for K, which is the one I'm going to choose to do because I like those numbers a little bit better. So I know at a time of zero, the concentration is 1. I can use any other point in time. I'm going to go ahead and use this one. At a time of 250, the concentration is 0.29. So this value is A naught. This value is A at some point in time, and that point in time is 250. Depending on which set of data you pick, you're going to get an answer that's slightly different. So 1 over 0.29 equals K times 250 plus 1 over 1. So 1 over 0.29 minus 1 gives me 2.49 equals K times 250. Divide by 250. This was not looking for units, but since it's second order, it'll be m negative 1, s negative 1. Depending on which approach you took to finding K, you're going to get something close to this or something like 0.01 if you did it by finding the slope of the line. Different approaches will get you different answers, but they're all going to be in this ballpark. So that's my answer for A. For B, finding the half-life of the reaction. We don't normally talk about half-life in context of second order reactions. But if we're literally going for the definition, how long does it take for half of something to disappear? Well, if it started off at 1, what's half of 1? 0.5. How long did that take? 100 seconds. When you don't do any work to do it, they call it solving by inspection. For C, I need to find the concentration after 300 seconds. So I'm going to use second order rate law again. I'm going to plug in the K that I found, and I'm going to use a time of 300. I'm solving for A. This one, it's positive KT. So that number times 300, and I have 1 over A equals 2.94. And the concentration of A will equal 1 over 2.94. 0.34 molar. I can look back up at my data and see if that makes sense. That does not make sense. Correcting that, I forgot to add the 1 in here, so it should be 1 over 3.94, which gives me the concentration of A equaling 0.253 molar, which does make sense because it's lower than my 0.29.